I want to brighten up brain injuries. And no, I don't mean that I want us to be more positive or optimistic about them. In fact, I actually think we should start taking them a little bit more seriously. In just the 3 minutes I have to talk to you, one Canadian will suffer from a brain injury. That adds up to 170,000 brain injuries every year in Canada, resulting in 11,000 deaths and 6,000 individuals left permanently disabled. Despite these facts, there is still no single standard objective criterion for diagnosing concussions. There is a glaring void in concussion diagnostics. My research looks to fill that void with the development of a novel technique for visualizing concussions by brightening them up. So how are we going to go about doing this? Well, we start with the severely injured brain, as you can see at the bottom of my slide. When an individual receives a brain injury, astrocytes flock to the scene of that injury, like first responders to the scene of an accident. I also like to think of astrocytes like the scab of the brain. When you cut your arm, a scab forms so the skin can heal correctly. Similarly, when you injure your brain, the tissues and cells in that area essentially turn to mush. So the astrocytes form a scaffold around which the cells and tissues can heal and reform correctly. The only difference between the two is that a doctor can see the scab on your arm and know that you're injured, but they cannot see the scab in your brain. I want to make this brain scab visible. So I looked at proteins associated with astrocytes, the cells that make up this scab, one of which is S100B, a protein associated with astrocytes that sheath blood vessels and involved in inflammatory processes. When an individual receives a concussion, the concentration and expression of S100B are significantly increased in the area of the injury. It is that increase in concentration that I want to image. So I synthesized a fluorine-18 containing compound specifically designed to bind to S100B. Once that compound is bound, it can effectively be imaged through the use of positron emission tomography, or PET for short, which measures the energy from the radioactive decay of the fluorine-18, and it depicts that energy density in a handy-dandy 3D image using a big, bright red spot, as you can see in the picture at the top of my slide. And that big, bright red spot highlights where the injury is found in the brain, and it also lets us know whether or not an injury is present. Therefore, with the successful completion of my research, as outlined on the slide, we will have an effective and objective way of diagnosing concussions by brightening them up.